Hello, how are you doing today? This is Professor Ramkrishna and welcome to my YouTube channel Archiversity. This channel provides hundreds of video lectures on finance, statistics, data analysis and all. In this lecture or in this video, I'm going to explain you the concept of coefficient of a variation. So coefficient of variation is a measure of a dispersion used most frequently in financial analysis as well as in statistics. So I'll explain you the concept, its implications, also show you how to calculate a coefficient of a variation and interpret the result. Keep watching. First, let me introduce the concept of a coefficient of a variation to you. So in statistics, coefficient of a variation, denoted as a CV, is a measure of a dispersion. Dispersion is a deviation of a given data points around the mean value. Let us say you have a mean value here and your data spread somewhere here. So your coefficient of variation measures this dispersion, in the sense how scattered the individual data points from its mean value. And it is also known as a relative standard deviation because it measures the relativeness between the standard deviation and a mean value. That is, the CV, that is the coefficient of variation, is a ratio of a standard deviation and a mean value. So when we say a ratio mean, so you have two variables, one is a standard deviation and second one is a mean value. That means standard deviation to mean value, which indicates that the standard deviation upon mean value. So your coefficient of variation equation is that simple. It is a relationship between two. One is a standard deviation and a mean. So as a ratio we express A is to B, or that is standard deviation is to mean value. So standard deviation mean, and it is expressed in percentage terms. When you are saying that percentage terms, you need to multiply this with 100. So here our value and multiply this with 100. So you got the formula for calculating a coefficient of a variation. Now the higher the CV, the higher the dispersion. In the sense, if you have a higher CV value, that is the coefficient of variation value, the dispersion is very high, in the sense your values are scattered very far from your mean value, or no uniformity was there. Then the coefficient of variation in isolation, it may not be of a great help, but it is useful to compare results of two different surveys or two different data series. So suppose individually, if you have a coefficient of value of a 20%, so it may not indicate much. Simply you can tell that so your observations are deviated high or low. But when you have two series like a COVI of 1, that is a 10%, and covariance of a 2, this is a 15%, then we can say that when comparing coefficient of variation of 1 with a 2, so coefficient of variation has got a less dispersion, whereas this has got a high dispersion. When we say that you have high dispersion, mean it is highly difficult to predict the values. Or we can say that the series with a high CV is a more volatile. So that means this series is a highly volatile when comparing with the previous one. Now the lower CV, in opposite to the higher CV, the smaller residuals related to the predicted value. So your residuals are small to the predicted value. That means your model is close to accurate and prediction can be effective. Now we'll see how to calculate the coefficient of variation. Now, as you already explained or already know the formula, so this is the same here. So suppose if you have a population, then we use the population standard deviation and population mean times 100. And if you have a sample data, then sample standard deviation and mean of a sample times 100. So here we have two examples, like one is a regular test and second one is a randomized. Using these two, we calculate the coefficient of variation. So first one, we can say that coefficient of variation of a regular test, I'll indicate as a T, and second one is coefficient of a variation of a randomized answers, we indicate as A. So our formula is standard deviation upon mean times 100. So here also this is standard deviation times mean into 100. So here our standard deviation value in a regular test is 11.2 upon mean value is 50.1 times 100, whereas for randomized answers your standard deviation value is 12.9 and mean value is 48 45.8, this times 100. So our coefficient of variation values is 11.2 upon 50.1 into 100. So this is 22.35, whereas for the randomized answers, this is 12.9 upon 45.8 into 100. So this is a 28.16. So in this case, your randomized answers has higher coefficient of a variation. So higher coefficient of variation indicates that in case of a randomized answers, this is the data points are highly volatile or scattered when comparing with regular test. In case of a regular test, the CV is low, that is 22. So this is how you need to calculate the coefficient of a variation and compare it with two or multiple data sets, and then interpret the result. So the logic is very simple. If the higher the CV, then it is the data points are highly dispersed or having a high volatility, and when your data series has got a high volatility, then prediction going to be very difficult. So thank you for watching this lecture on coefficient of a variation. When time permits, please visit Archiversity website or Archiversity YouTube channel and go through with hundreds of video lectures and enhance your learning. Have a great day.